In this video, I'm going to do a quick review of Pascal's triangle. Now, Pascal's triangle you'll see on the left here. This is Pascal's triangle. Now, the way it's constructed, the way we build it, is if you imagine that anywhere there's not a number written, there's a zero. So you can imagine there's a zero here and a zero here. And how we're always building is diagonally. Two numbers added together make the number in between. So 0 plus 1 makes 1. 0 plus 1 makes 1, so on and so forth. So if you kind of build through the triangle, you'll see, like, for example, 1 plus 3 makes 4, 3 plus 3 makes 6, and so on. Okay, so let's see if you could, on your own, pause the video, give it a try. Can you build the next row of the triangle that I have not written? And I will go ahead and do that now if you are unsure. So it'd be 1, 6, 15, 20, 15, 6, and 1. Because remember, that if there is no number written, there is a 0. So 1 plus 0 makes 1. Okay, so hopefully you got that. Now, how do we use it? In calculus, one thing we can use it for is expanding binomials rapidly. Please note that the x plus h to the 0, I'm hoping no one will ever do in calculus. But notice 1 equals 1. Next, the next line, x plus h to the first, x plus h, 1, 1 in the triangle. How does the triangle help us? Well, it may not be totally obvious yet. Let's go one more row. X plus h squared is x squared plus 2xh plus h squared, 1, 2, 1. So hopefully you're recognizing that the triangle gives us the coefficients on our terms once we've expanded. So you can see the 1, 3, 3, 1 when we go to the cubic row, or the cubed row. This would be 1, 3, 3, 1. You can see there's a 1, 3, 3, and 1. Okay, so now you might be saying, great, I have the coefficients. How do I come up with the rest of it? Well, the rest of it's actually kind of the easy part because it follows a simple pattern. When we multiply x plus h out, when we distribute it through, when it's through the fifth, or expand it, it distributes out to, or expands to, x to the fifth plus 5x to the fourth h plus 10x cubed plus h squared, so on and so forth. And hopefully you remember the coefficients are coming from the triangle. So how do you get the rest of it? Well, if you notice, each term, when you look at the two variables, x to the fourth times h, x to the fourth is 4, h is raised to the first, so therefore 4 plus 1 makes 5. X cubed h squared, 3 plus 2 makes 5. That'll always be true. The exponents are always going to add to make the degree of the power of what your original binomial is raised to. Another very simple way of coming up with this pattern is the x's, the first term counts down. So x to the fifth, next term is x to the fourth, next term is x cubed, next term is x squared, so on and so forth. And the h's, or the other, whatever the other term may be, always counts up. So we start with h to the 0, that's why we don't have it, then h to the first, second, third, fourth, and fifth. So hopefully using this pattern, you can see what to do for the next one. So I would highly recommend try it yourself, pause the video, and here we go. So I know it's going to count down. So I'm going to start with x to the sixth, then I'm going to have x to the fifth, h to the fourth, sorry, try again, h to the first, because that counts up, plus x to the fourth, h to the second, plus x cubed, h cubed, and I'm also keeping in mind these have to add to make 6. X squared, whoops, let me leave a little space there, x squared, h to the fourth, plus x h to the fifth, plus h to the sixth. Now, I'm almost done. I just need coefficients. And there they are, because we already did them in our triangle. So what will this end up being? 1. The next coefficient would be 6, 15, 20, and then I believe it's just going to repeat itself down. Yep, 15. Excuse me. 15. Then we have a 6, and then we finish with a 1. And there we go. We have multiplied through. We have expanded the binomial of x plus h raised to the 6th, and it did not take us half of our life. Okay, one more thing we need to talk about before we move on is what if it's not plus? what if the thing we are distributing is a minus? So if it was x minus h, well, it's actually really simple, and you can memorize the pattern, but I always like if you understand where it comes from. Just think of this as being a negative h, so it's x plus negative h. So for the first term, x, if we were to distribute all this through, it would be x times x times x, which is give us x to the 6th. Since they're all positive, it would be x to the positive x to the 6th. Now here we'd have 5 positive x's multiplying 1 negative h. So a positive times a positive times a positive, so 5 positives, positive times positive times a positive times a positive times a positive times a negative would make the whole thing negative. So then similarly, for the next term, we would have 2 h's because it's h squared, so a negative times a negative would make it into a positive. And so what's going to end up happening is, if you go through this pattern, you're going to recognize that anything that has a odd number of h's will become a negative, anything that has an even number will become a positive, and it just ends up alternating, right? Positive, then negatives, then positive, then negative, so on and so forth. So that's kind of it to this. So if it's a x minus h, or whatever it may be, just think about how many negative signs you have when you're multiplying through, and you'll get your answer. Okay, and I also just want to show you that Pascal's triangle can be used in other parts of mathematics as well. So if you learn it now, it'll help you later. One example is the concept of combinations when you're doing probability. Now, we're not going to do combinations in here, so don't really worry about understanding it. So if you want to, you can turn off the video right now. But the idea here is combinations is when we're choosing groupings of something. So for example, if I had 5 friends, friend A, B, C, D, and E, and I was going to choose 2 of them to go on a trip with me, how many different groups are there? Well, I could have friend A and B, I could have friend A and C, A and D, A and E, or I could take A, sorry, no more A's, that's all my combinations of A's, because A and B and so on. Then I could have B, C, B, D, B, E, and then I could of course have C, D, C, E, or I could take friend D, E. So let's count this up. This would be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There are 10 different combinations of friends that I could bring with me. Or instead of making gigantic lists, because I'm sure all of you have more than 5 friends, but nonetheless, we could use combinations, which is this formula here. So out of my 5 friends, I'm going to choose combinations of 2, and the math works out to say 10. Now, how is this related to Pascal's triangle? Well, if I go to my powers of 5 row, and I go to the trick is we start at 0. So this would be 5 choose 0. This one would be 5 choose 1, and right here is 5 choose 2. 5 combinations 2. And so therefore you can already guess what 5 combinations of 3 would be is 10. Right? So if I choose 2 friends to go with me, there's 10 different ways of doing that. If I choose 3 friends to go with me, there's 10 different ways of doing that. So there is a relationship. So if instead of building the entire triangle, if you only needed one number out of the triangle, instead we could use combinations, or vice versa. If you just needed a ton of them, you could just build a triangle really fast and see all of your answers without having to do all the combinations calculations. All right, I hope this video helped and refreshed a little bit of memory.